Hi guys, in this episode of Shri series, we're going to be talking about stoichiometric questions, and we've got a question right here, so I'll just read it out. What mass of aluminium can be dissolved by 45.6 ml of 0.132 mole per liter hydrochloric acid? All right. Now, before I go any further, it's important to notice that this question is given just like that. There is no chemical equation given to you. You need to write down the chemical equation. You need to know what do we get when we have an acid reacting with a metal. All right. These are the sort of questions you're going to be given, particularly in year 11 chemistry exams. All right. 8 chemistry exams where you'll be given the question exactly like this. You need to write down the chemical equation. You need to write down the appropriate state symbol, and the chemical equation needs to be fully balanced. All right. So you got to write down the equation, and then we need to see what information is given to us. So I'm going to show you and take you through a step-by-step process to solve this question here. All right. So you can see I've already underlined what important information is being given. So you can see we have our volume, and our volume is 45.6 mils or milliliter, and my molarity is 0.132. All right. Now, some textbooks use capital M, or some textbooks represent it as moles per liter. Just remember the unit for molarity is moles per liter. Okay. Now, let's now write down the chemical equation, because that's a very important aspect. Okay, so we have a reaction between aluminium and hydrochloric acid. Now, when an acid reacts with a metal, you get salt and hydrogen. So in this case, my salt is aluminium chloride and hydrogen gas. We need to balance this equation. We want to ensure that the equation is correctly balanced. We've got solid aluminium in aqueous hydrochloric acid to get aluminium chloride and hydrogen gas. Now, the first question we need to ask is this equation fully balanced? All right, so I don't think it's balanced. So what we now need to do is we've got to get, we put 2 there. So there's 2 aluminiums there. We've got 6 chlorines, and we've got, we put 6 there, and that puts 3 hydrogen. Now my equation is fully balanced. I've got 2 aluminiums on one side, 2 on the right hand side, 6 hydrogen on my reactant, 6 hydrogen on my products, and lastly 6 chlorines. All right. It's very, very important that your equation has to be correctly balanced. Okay. And I will show you at the end why this question can be absolutely risky, particularly when you're not too sure with equations and valencies as well. All right. So we've got the equation fully balanced. The next thing we need to do is we've got this information is pertinent to hydrochloric acid. We've got my volume there, which is 45.6 mils, and we've got our molarity, which is 0.132 moles. We know very well the formula for moles in this case is molarity times volume. All right. So some textbooks, in place of M, they put C and they put N here. So we know very well N is equal to C times V, or CV. All right. So the number of moles we've got here is molarity, which is 0.132 times 45.6. And we need to divide it by 1,000 because the unit for volume in this case is liters. And we know very well 1 liter is 1,000 milliliters. Therefore, 45.6 milliliters needs to be converted to liters. All right, so let's calculate that. So 45.6 divided by 1,000 multiplied by 0.132. And we've got our moles of HCl as 0.00602. All right, that's the number of moles. The next thing we need to work out here is we've got the moles of hydrochloric acid. The question's asking to get the mass of aluminium. All right, so we know very well, we know the connection between mass and moles. All right, we know from the previous basic equations, and I'll just write this down here. We know that mass is relative atomic mass times the number of moles. I'm using relative atomic mass is because we're looking at aluminium. All right. Now, if this was aluminium chloride, then in place of RAM, I would put RMM, which is relative molecular mass. So we know very well that in order to get the mass, we need to get the relative atomic mass of aluminium, which we know that's 27. You can look at that information from the periodic table. And we need to get the number of moles. Now, this is what we need to look at. This is our prime target to get, because once we get the number of moles, we can multiply it by 27 to get the mass. So this is just to give you guys a heads up. So this is where you know where you're heading to. So let's look at a concept called mole ratio. All right, mole ratio. I like to consider this a bit like mathematics, because a mole ratio tells you the exact number of moles based on the coefficient in a balanced equation. If you look at the mole ratio between aluminium and hydrochloric acid, you can see there's 2 moles of aluminium reacting with 6 moles. All right, so you can say 2 moles of aluminium reacts 6 moles of HCl. All right, so I mean, that's literally how you interpret the mole ratio with reference to the coefficient. The fact that you've got 2 as a coefficient in aluminium and 6 as a coefficient in hydrochloric acid, what that means is you can see that 2 moles of aluminium is reacting with 6 moles of hydrochloric acid. Now, you can see here we've got the number of moles of hydrochloric acid. So the question we want to find out is, if 2 moles of aluminium reacts with 6 moles of hydrochloric acid, how many moles of aluminium therefore would react with 0.00602 moles? That's literally the basis of mole ratio. It's as simple as basic arithmetic. If 1 pen costs $3, how much will 4 pens cost? All right, $12. It's literally like that. So whenever I explain this, the concept of mole ratio to my students, I tend to bring them back to the basics of arithmetic. All right, so if 2 moles reacts with 6 moles, or more specifically 2 moles of aluminium reacts with 6 moles of hydrochloric acid, what about 0.00602 moles of hydrochloric acid? How many moles of aluminium are we going to get? So this is where you can get the mathematics. Some people tend to use this as an X to say that, look, this is the unknown. Let's call the unknown as an X. We call it X moles of aluminium. So what you now need to do is you're going to cross multiply. All right, if 2 produces 6, what about 0.0602? So what you do in this situation is you go 2 times 0.00602 divided by 6, which is technically 1/3. If you look at the scope of things, it's actually 1/3. Then you work out your answer. What you get here is you're going to get 0.0020264. All right, so that's going to be 0.00264 moles of aluminium. All right, now that's not the final answer. I know a lot of students tend to make that mistake. They say, oh yes, I've got the number of moles, but you must remember you're told to find the mass. It's very important that you find the mass, because that's what's going to give you the answer. All right, so let me just sort of zoom this a little bit so you can see what we do from there. Okay, so therefore my mass of aluminium is now my moles multiplied by my relative atomic mass. Okay, so what we'll do here is I'll just put a line there just to show you what's the next step. All right, so what we get here is 0.00264 multiplied by 27, and you should get 0.054 grams of aluminium. All right, so that's literally how you work through this point here. All right, let me just zoom this a little bit so you can see. Okay, so that's how you solve these questions involving stoichiometry. Now, when you first look at this, for the first time, a lot of students get overwhelmed because they go like, oh, wow, I need to get my equations correct. They've got to be balanced. I need to get the moles, so I need to know what formula is required to calculate moles. Then I need to apply my mole ratio, and then I need to use the last formula to get there. So let me just break this down into simple components. So in that way you can understand. I will be putting other questions as well, but this is important. The first thing that is very, very essential is you need to know your valencies, cations and anions. You need to know them very thorough. All right. If you didn't know that aluminium chloride is AlCl3 because aluminium's valency of 3 plus and chlorine's valency of -1, you're going to get that wrong. The next thing is you need to be very thorough with your acid reactions. All right. In this case, it's an acid and a metal reaction that produces salt and hydrogen. If you didn't know that an acid and metal produces a salt and hydrogen, you're going to get this answer wrong. The next thing is you need to know the formula to get moles. What formula connects moles, molarity, and volume? If you don't know that, this question is going to be hard for you. The next thing is you need to be very thorough with using mole ratio. Like I said, it's like basic arithmetic that you learn. And the last one is this formula here, where you need to know the relationship between mass, moles, and relative atomic mass or relative molecular mass to get to this answer. All right. Thanks for listening, guys. Bye now.